For the commercial glider knowledge test, the FAA takes the glide ratio problems you're used to and makes them more complex. Now, in addition to your normal lift to drag ratio, you're also going to be given either a headwind that pushes against you or a tailwind that carries you, and you'll be asked to compute an effective L over D of what the glider's actually doing over the ground. The hints that we're used to of writing down what we know, drawing a picture of the L over D lift to drag ratio triangle still apply. Now we're also going to be doing this step twice though, to use that information we find to compute a new effective L over D, effective lift to drag ratio. Again, the approximation that a nautical mile is 6,000 feet is still totally valid. And as you see from the next two examples, we can break this problem down and make it very simple. If you're having problems with questions like these, again, you can subscribe to this channel for additional help. Also, if you need one-on-one mentoring, you can reach out to me through the link down below and schedule a mentoring session where you can ask me any questions you need to know about the knowledge test, your rating, or how to do your check ride. Okay, for example 1, we have the glider has a normal L over D ratio of 23 to 1 at an airspeed of 50 knots. What would be the effective L over D ratio with respect to the ground with a 10 knot tailwind? Okay, and again, our materials, we brought our E6B flight computer. We've got a mechanical pencil, and then we're given the mechanical pencil, and we'll be given pen or paper to use. Okay. So we know we have an L over D is equal to 50. Is equal to 20. Is equal to 23 to 1. Excuse me. Okay. And we know that it's normally going. So let's draw our L over D triangle. Okay. Oops. 1 is to 23. And we know that 1, and this could be 1 nautical mile to 23 nautical miles, but it's much more useful to talk about it in terms of 1 nautical mile is 6,000 feet, 23 nautical miles. We also know that we have this normally happens at 50 knots. Okay? 50 knots. Okay? 50 knots. This looks like our standard L over D problem. Remember, if we add the 10 knot of tailwind, okay, these no longer become similar triangles. That's why we can compare L over D to what the glider is actually doing as it flies through the air, because there's similar triangles. But once we add on, okay, a 10 knot tailwind, okay, and extend it out, okay, this larger triangle, let me make that a little more distinct, is no longer a similar triangle. We have to use the original 50 to some number. Okay, this is a two-step problem, but as a commercial pilot, you're not worried about that. So L over D, 23 nautical miles over 6,000 feet is equal to 50 over, and this is 50 knots, okay, nautical miles per hour over question mark. Just take our flight computer, 23 over 6,000. So we find 23 over, 23 right there, over 6,000. 23 over 60, 23 over 6,000. 50 over question mark. So we'll rotate the calculator. Okay. It's over 13, we'll just say that's 13.1. So in our case, question mark is equal to 13,000 feet per hour. Okay, because it was nautical miles over feet. Feet was on bottom. So if this is nautical miles per hour, this has to be feet. Nautical miles per hour. Feet, so therefore below we have to have feet per hour. 13,100. Okay, 50, and then below we have 13.1. Okay, now we've solved the first step of how much we'd be going down. Now we need to do, because it's a commercial level problem, we have to do the next step, which is now we have a 10-knot tailwind. Okay, so now here's our original triangle. 13,100 feet per hour, and we're going 50 knots, but we have a 10-knot tailwind. So we'll add, it's not perfectly to scale. That's supposed to be a dashed line here. Okay, so it's 10, okay? A 10-knot tailwind. So it's obviously that wind would be pushing us 10 additional knots because it's a tailwind. So the thing we have to realize here is we're doing it over this entire length now. 50 knots plus 10 knots equals 60 knots, obviously. Okay, and then we need to find the effective L over D. What is that effective L over D? Well, we always do it over 6,000, right? And we don't know what this is. But there we just did the addition. So now we have a number here for the L. We have the D. We always have our 6,000 for 6,000 feet in a nautical mile, and we don't know what that is, what the distance is going to be. Okay, when we have the tailwind. So L, 60 knots over 13,100 feet per hour equals some question mark over 6,000 feet. So we have 60 over 13,100. Okay, 60 over 13,100. 60 over 13,100. And we have a question mark over 6,000. So we want to find the 6,000 below. There's 60. And then we look above it to find what it is. Okay, 25. There's 30, 25, 26, 27, 27 and a half, 27 point. The answer is 20. The answers that are available is C, 27.6. I can believe that. So question mark. Oops, it's a question mark. Let's erase that. Equals 27.6. Okay. So the answer is C. Okay. Next one. Okay. Now, if we had a tailwind problem before, you know what's coming next has to be a headwind problem. Okay, example 2. The glider has a normal L/D ratio of 30:1 at an airspeed of 50 knots. What would be the effective L/D with respect to the ground with a 10 knot headwind? Okay. So we know, again, write down what you know. L/D equals 30:1. Okay, let's draw the triangle. (30:1). Okay, and then we know that that 30:1 usually happens at an airspeed of 50 knots. Okay. Again, we could say that that's 30 nautical miles to every 1 nautical mile. But of course, nautical miles are not particularly useful. Our altimeter isn't read in nautical miles, it's read in feet. So let's change that to 6,000 feet. Okay. And then we just set up our L/D equations. 30 nautical miles for every 6,000 feet equals, okay, 50 knots over question mark. And then we could just easily solve for that. Okay, 30 over 6,000, so 30 over 60. Let's find our 30. Okay, we rotate it to get our 60 directly below it. 30 over 60, 30 over 6,000. Yep. 50 on the top, so we rotate it. Oh, right over the 10. Question mark equals 10,000 feet per hour. Okay, now we have the next part of our question is, now we have a 10 knot headwind. Okay, so normally we'd be going at 50 knots. Oops, draw that a bit bigger. Make it a lot easier if I draw it bigger. Normally we'd be going 50 knots, but we actually have a 10 knot headwind. 10 knots of headwind. So now it's actually, instead of extending our glide, it's actually reducing our glide. Okay, and so this distance now here is actually 50 knots. Write that more clearly. 50 knots minus 10 knots. Oops, KTS equals 40 knots. Okay, we're still going down. Okay, and we're going 50 knots in the air. We know we're going down 10,000 feet per hour. 1,000 feet per hour. Okay, and now we're trying to find out what our effective new L/D is. And it's going to be shorter. We know that I'm drawing a shorter triangle to indicate that it's going to be shorter. We don't know how far out we're going to go. We know we're still falling down at the same, we're still descending at the same rate per hour. Okay, but now we can set up our triangle just like we so set up our ratios like we normally would. So now we have 40 knots divided by 10,000 feet per hour equals, oh, excuse me, 6,000. I meant to say 6,000. 6,000 feet, okay, over 6,000. Because again, we're doing our ratio. 1 nautical mile, your altimeter isn't read in nautical miles, it's read in feet. So it's much easier to put it in that 6,000 to 1. rate approximation for what a nautical mile is. So 40 over 10. Find 40 on the outer scale, put 10 for 10,000 on the inner scale, and we've got 6,000, and we're trying to find out what's above it, what that question mark is. Okay, so we'll rotate the inner scale till we find 60. Look above it. 60 stands in for 6,000. 24. Okay, oops, question mark equals 24. So therefore, the question mark is equal to 24 nautical miles, which in our case would be, so the answer is B, 24 to 1. And that's what the FAA wants you to know about effective lift to drag ratio problems. If you're having difficulty with problems like this, click on the playlist above and you'll get tips and tricks so that way you can ace your FAA knowledge test.